everyone, my name is Desinta Dewi, and here I want to continue my explanation about the Senior Mechanical Lab experiment. So at the part 1, I have explained until the heat transfer setup, which is about heat conduction. Here I want to continue to the thermodynamic setup. So the thermodynamic setup actually similar to the heat transfer setup. From the heat transfer experiment, I noticed that there is a thermodynamics phenomenon which is phase change in water. So here I want to prove the temperature versus time graph of the water phase change. Actually, we can do the heat transfer experiment and this experiment together at the same time. So let us directly go to the experiment. So in this experiment, the setup is able to show the heat transferred from the electric stove or the heat source to the ice bath or the heat receiver. As the heat transferred to the ice bath, the ice will receive the heat and change its phase. In this experiment, we will measure the temperature change of the water. Actually, we can also calculate the heat required for the phase change in water. However, because the time is limited and I don't have the weight scale to measure the mass, I don't calculate the heat. So here is the tools that we are using for this experiment. It is similar to the heat transfer experiment. We need electric stove, pot filled with ice water, thermocouple, and Arduino. This tool is to measuring the temperature. However, because I do this experiment by my own tools, the heat transfer setup already sent to my. However, because the heat transfer setup already sent. However, because I already sent the heat transfer setup. So here is the tools that we are using for this experiment. It is similar to the heat transfer experiment. We need electric stove, pot filled with ice water, thermocouple, and Arduino. This tool is to measuring the temperature. However, because I have sent the heat transfer setup to my friends, so I create this experiment by using the tools that I have in my home. So for the electric stove and pot filled with ice water, I change it to electrical pot. And for the thermocouple and Arduino, I change it into the cooking thermometer. And here is the working principle of the phase change. So in the phase change of water, there is 5 stages. This is the stage 1, the temperature change from the ice temperature into 0 Celsius. So 0 Celsius is the melting point of the water. And then the stage 2, the phase change from solid to liquid, or the water is melting. Then on the stage 3, the temperature change to the 100 Celsius or to the boiling point of the water. And then the stage 4, the phase change from liquid to gas or vaporization. And the last stage is the temperature change to more than 100. So this experiment is proposed to compare this graph with the graph that we will obtain during the experiment. So here is the setup, and the method of this experiment is very simple. First, you need to put the ice on the electrical pan and check the ice temperature by using the thermometer, and then starting to turn on the pan and record the temperature in some period of time. And the last one is draw the graph of temperature versus time. In this experiment, I record the video showing the temperature value which displayed on the thermometer, so I can easily look at every temperature change. Then I take a note the temperature value every 30 seconds, and it is as shown in these tables. Then by this time and temperature data, I get this graph of the temperature and time. Unfortunately, the temperature of the ice that I have is just until minus 0.3 Celsius and cannot be lower than that because it keep constant at that temperature. So we cannot really see the stage 1, this one. For the stage 2, we can see it a little bit at the beginning of this graph, but it is not this long. The next is for the stage 3. We can see it clearly here that it has a slope, however it fluctuates at some point. Then on the stage 4, it also show the similar things with this one, with some fluctuation, and it is not really straight. In stage 4, the temperature So if we're looking at this heating curve for water, in the stage 4 the temperature is constant at the water boiling point, which is 100 degrees Celsius. However, in my experiment, the maximum value that I can get is 96 Celsius. I have several guesses why these things can happen. The first one is because of the temperature. I have several guesses why this thing can happen. The first one is the thermometer. The thermometer claims that it can measure the temperature from minus 50 until 300 degrees Celsius. However, I never use it until that temperature, so I cannot make sure whether my thermometer really can work at that range or not. And the second one, it is maybe because of the electrical pot. So maybe the maximum heat that can be produced by the electrical pot only can heat up the water until 96 Celsius. However, I don't know which is it true or not. It is just my guess. So in conclusion, this setup can show that there is heat transfer from the electrical pot to the ice. The phase change from the ice to liquid also can be clearly seen. However, we cannot see all of the 5 stages in water phase change because of the limitation of this experiment, like the lack of materials and something like that. Better experiment equipment may be used to obtain correct and more accurate result. Okay, then let us move on to my last experiment for the fluid mechanics setup. It is Reynolds number experiment about laminar and turbulent flow. So, in this experiment, the setup has the purpose to visualize the laminar and turbulent flow. Here we can measure the volumetric flow rate and fluid velocity. When the volumetric flow rate changes, the fluid velocity will also change. The change in fluid velocity can make the flow pattern change also. The tools that we are using in creating this setup, such as water tank, transparent pipe, infuse set, measuring cup, faucet, printer ink, cutter, scissors, and some tapes. Okay, then how to assembly all of these tools become the fluid mechanics setup? Here's the method. 1. Create a hollow on the below part of the water tank. The hollow size is the same as the diameter of the transparent pipe. So the hollow will be here. 2. Insert the transparent pipe into the hole, then seal the area around the pipe and hole by using tapes. Make sure there is no leakage in here, so the fluid will not go out in this point. 3. Put the infuse set inside the tank and the pipe. we put the infuse set so that the needle are inside the transparent pipe and the chamber are on the outside of the tank. 4. Install the faucet at the end of the transparent pipe. Use the tape to make sure there is no leakage. Again, make sure there is no liquid leakage in this point and this point also. 5. Place the water tank at least 50 centimeters above the ground, like this. 6. Because previously I said that the chamber is located at the top of the tank, here you need to put the chamber or ink tank approximately 10 centimeters above the water tank, like this. Next, here is the working principle of the Reynolds number experiment. So, the Reynolds number is the ratio of inertial force to viscous force. This dimensionless number depends on the geometry of the pipe and the physical properties of the fluid, such as density and viscosity. In fluid flow, there are 3 types. They are laminar, transient, and turbulent. Laminar flow occurs when a fluid flow in parallel layers with no disruption between layers, as you can see here in this figure. Transient flow means the flow is in transition, so in this flow can have laminar or turbulent. And the next one, turbulent flow, is irregular flow that is characterized by tiny whirlpool regions like this. You can see, right, there's a lot of whirlpool here. In the Reynolds number experiment, we are observing the fluid velocity and the flow pattern. Why we observe the fluid velocity? Because we need to find the Reynolds number, and the Reynolds number can be obtained by using this equation. However, the value of the fluid velocity is not known yet, so we will use the volumetric flow rate equation to find the fluid velocity. Also, as I said here, this experiment also observing the flow pattern of the ink inside the water, and here is the expected result of the ink. So, in conducting the fluid mechanics experiment, I divide it into 2 parts. The first one, I do 2 experiments to obtain the Reynolds number. So here I record the volumetric flow rate of the water and do some calculation, etc. And the second one, I do several experiments to obtain the turbulent and laminar flow pattern. In here, I just saying the pattern and ignoring the value of the volumetric flow rate. So I will just showing the video and I don't do any calculation in this one. Next, here is the list of parameters that needed for the analysis of Reynolds number. The constant variable in this experiment will be the pipe diameter, viscosity, and density of the fluid, and the value of those 3 is as shown here. We assume the water is at 30 degrees Celsius. At the first experiment for Reynolds number, I slightly open the faucet, then 1000 milliliters water can flow in 72 seconds. The volumetric flow rate and fluid velocity can be calculated by using this equation, and I get the result here. Then I calculate the Reynolds number by using this equation. Then here is my result. Because this value is between 2300 and 4000, so the flow types is transient. Here is the experiment 2 of Reynolds number. In here, I open the faucet wider than the first experiment. Then the 1000 milliliters water can flow in 40 seconds. The volumetric flow rate and fluid velocity is as shown here. And calculating the Reynolds number by using this equation, I obtain this value. Because this value is more than 4000, so the types of flow in this experiment is turbulent. Next, I will show you some video about the This is the conclusion of the fluid mechanics experiment. By this experiment, I found that if I open the faucet wider, the fluid velocity will be increased. As the fluid velocity increase, the Reynolds number will also increase. And the fluid flow types will be changed. And the second conclusion is, I think there is still some errors during my experiment, such as 1. The leakage on the infused pipe and the needle. This leakage makes the flow pattern of the ink cannot be seen clearly. And the second one is the volumetric flow rate value is, I think it is just approximation, because in my experiment I feel that the volumetric flow rates is not constant. So for more accurate analysis, maybe we can use volumetric rate meter or another device like that. Now I will tell you about the overall conclusion and feedback about this course. First, what I have learned about this experiment. Of course, I learned about the heat transfer by conduction in real life, and I learned to analyze it directly. The second one, I learned how to make the laminar and turbulent flow, how to change the volumetric flow rate so that I can get laminar or tension or turbulent flow. And the last one, I understand better about the phase change in water. And from the class activity, what I get is the teamwork, of course, because this is a group assignment for 1 semester. Second one, time management, and then analysis skill and problem solving. And about the feedback for this class, overall, I liked how Mr. Jati arranged the activities in General Mechanical Lab class. He let us to be creative about what will we do for the experiment. And he always monitoring each of our progress, which is very good. However, I'm a bit sad because we cannot do the real experiment on SU Lab, which is, I believe that it has good facility, so we can minimize any error during the experiment. Also, since we do the experiment at home, honestly, sometimes I feel lazy to do the experiment, but when I already do the experiment, I feel like it, and it was fun of conducting the experiment that we designed it by ourselves. So yeah, that is about my feedback. I enjoy this class, and thank you Mr. Jati, thank you my friend, thank you everyone.